Today we're going to be continuing on with our looking at radicals, but we're going to add in some variables. So we're going to have two rules that we're going to use. So we have square root of a raised to the mth power. So if m is a multiple of 2, we're going to use the rule square root of a raised to the mth power equals a raised to the m divided by 2. If m is not a multiple of 2, so if it's an odd number, we're going to break it apart. So we're going to take it and do square root of a to the m minus 1, so it becomes an even number, so it is divisible by 2, times a. So we're removing one a from that and breaking it into two separate radicals. So looking at example 1, so I have the square root of x raised to the second power. So looking at that exponent 2, it is a multiple of 2, so I'm going to use my rule where I take my base x, leave it there, do my exponent 2 divided by 2. And 2 divided by 2 is 1, or just x. Then I have the square root of 9 times k raised to the 10th power. So looking at this 9 first, the square root of 9, we know that is a perfect square, and I gave you guys your perfect squares cheat sheet so you guys can have that out where you're doing this and reference it. So the square root of 9 is going to be 3, and then we're multiplying that by, we have k raised to the 10th power. 10 is a multiple of 2, so we're going to keep that base k. We're going to take that 10 divided by 2. So we have 3 times k raised to the 10 divided by 2, or 3k to the 5th. Number 3, I have the square root of n raised to the 5th power. Now 5 is not a multiple of 2, so we need to take and remove one n from that. So we're going to do square root of n to the 5 minus 1 times, and then just an n over here. So this is going to become square root of n to the 4th times n. Then we're going to take this first one, and we can keep our base. Exponent is 4, divide that by 2, times square root of n. And then our final answer, we can take and divide those, so we have n squared square root of n as our final answer, because we cannot do anything with that radical n or square root of n because the exponent on it. Looking at number 4, I have the square root of 40 times a to the 19th power. So we need to simplify the 40, and then we also are going to need to subtract 19 because it is not a multiple of 2. So I'm going to take and rewrite this entire radical. So I know that 40, I can do 4 times 10. 4 is going to be that perfect square because it's 2 times 2. And then a, I'm going to take and subtract 1 from the 19. And then I have that remaining a there. So then I can remove from this radical the 4, because the square root of 4 is going to be 2. 10 is going to stay inside the radical. Then I have a to the 19 minus 1, which is going to be 18. So again, I'm going to take that out. A to the 19 minus 1, 18. And then inside my radical, I still have this 10 here, and then this a here, so 10a. So my final answer is 2a raised to the 18th power times radical 10 times a.